All right, we'll go and hope for the best here. Re-recording. Um, okay, we're back. So that's part one of the homework. Is you got to be able to print out a string. Part two is I'm going to ask you to take in 3 doubles. Okay, because I want double precision, so floating point operations that correspond to the coefficients for the quadratic equation, a, b, and c. And I'm going to ask you to use 2 nullable doubles, meaning they can be any double or null, to return 2 roots. The idea being that if there are no roots, you should return 2 nulls. If there's 1 root, you should return the root and a null. And then the final piece of this is going to be the whole program. Input 3 numbers, output a string in a nice way that tells me what the roots are. Either there are no roots, there is 1 root, this is the root, or there are 2 roots, these are the 2 roots. The tests are going to be really important because this is extremely precise text matching. It cares about what case you use for the letters. It cares about the spacing. It has to be all on one line, so you have to match it exactly. So that's why today's lecture in strings and manipulating those strings is so important. So let's just get all on the same page. A string is a sequence of characters. Each character in C is actually a Unicode character. Now, from previous courses, what type of characters did you deal with? Were they always Unicode? ASCII. That's where we started. ASCII, the American Symbolic Code for Information Interchange, ASCII. Fun historical side note. When I read that as a small child, I actually thought it was ASCII too, because I kept hearing people say ASCII, and then I saw Roman numerals at the end, so I assumed it must be the newer revision of ASCII, ASCII 2. But it's not, it's just ASCII. Those I's are not Roman numerals, so don't be like me. ASCII. Unicode was an extension of ASCII, and in fact, the base of Unicode is ASCII. If you take a Unicode character and you make the upper byte a 0, you have ASCII. And then we added on to that. So Unicode expanded, and it's actually still being expanded to this day. They're adding symbols, they're taking out symbols. The eggplant was the big thing last year. I don't understand that. That's beyond me. I can't InstaChat, snap face. It's a Unicode symbol there. So when we are representing this, each character, even though it says HELLO, those are not single bytes. They're Unicode, so they're usually 2 bytes or more bytes, or they're UTF-8 encoded, which is an 8-byte version, but we'll get there. When you say string in C#, it actually is referring to system.capitalString, which is a .NET type. So if you move over to Visual Basic, you can say string with a capital S, and it'll be the same as the C# shorthand. And all strings are in double quotes. That hasn't changed. The thing about strings, which may not be immediately apparent, is you cannot change them. Once they are made, you cannot edit a string. When something is read-only, we call it an immutable type. It is immutable as it cannot be mutated, which may come as a surprise because it's very legal to make a string like S, as shown on the screen, and then say S sub 1, or excuse me, S sub 0 is capital B. If you say S sub 0 equals capital B, it's a little bit strange, because that would seem to indicate that you could change the type. But what actually happens is a whole lot more interesting. It actually changes everything about the type. Strings are a reference type, and they're stored in the heap because they're a reference type. So when you have an array of characters, you can access individual elements. As we've seen, nothing has changed here from arrays of characters, from 0 to length minus 1. String.length is a property of the class, and it's actually an instance property. I know it says string.length, but you say s.length, s being the instance variable. And that'll give you the number of characters in the string. So you can print strings. You can print them either character by character via accessors, this indexer, that indexer. S sub I is called an indexer. That accesses an individual element of the string, and in this case returns a character. Or you can access the whole string. Console.WriteLine doesn't care what you use. It will access either of them. The backslash quotes in the second line there, console.WriteLine s equals backslash quote. That's how you actually print the quote character. If you didn't put that backslash or that escape character, it would think that the string was over, right? In order to print out a double quote, you have to put it in, you have to escape it. I'm not even going to bother showing that. Does anybody have any idea, any mystery about what's going to print here? Yes? I mean, we can do it, but all it's going to say is stand up, Vulcan Superman, which I remember from last year is the lyric to a song, and it's a weird song. Go Google it on your own time. It's on YouTube. It's very strange. It's lyrics to a song. The other thing it's going to print is the length is however many characters, probably what, 20, 25-ish. And then it's going to have 25 lines. S sub 0 is S. S sub 1 is T. S sub 2 is A. And D, so on and so forth. It's just to show that you can access the whole string or an individual element. Okay. Creating, declaring, reading, and printing. All three of the lines on this screen, string lowercase, system.string, string, are all the same with one proviso. The proviso is you have to have put using system at the top of your program. In order to use string, all in capitals, you have to have said using string. Now, the lowercase string, I believe, will work even if you don't have the using. System.string will work whether you have it or not. But they're all the same thing. It is a reference type, so when you first create a string, if you don't assign something to it, and none of those three lines assign something, it will have null. It won't have a blank string, it will have null. So there's a big difference between a string with nothing in it and a null pointer. Okay? You can initialize it in one of three ways. You can either put a string literal, double quotes, and whatever the values are. You can assign another string variable. You can say s equals t, if s and t are both string variables. Or anything that evaluates to a string type. There are lots of different methods that will give you a new string. So, by itself, it has null. You can use a string literal. That's just anything that's got double quotes around it. Any other existing string. And by the way, that will work even if s hasn't been initialized. When you say s2 equals s, if s hasn't been initialized, it's null. And you're allowed to assign null to a string because it's a reference type. So you can say string s, no initialization, it's null. Then you can say string s2 equals s, which also makes s2 null. But other than that, it doesn't have any value. And then anything that evaluates to a string. All objects in C# have a toString method. Everything can say .toString. It's one of the most basic clauses that an object can have. So you can say 42.toString, and you will get the string character 4, character 2. So anything that evaluates to a string. Readline, as we've seen over and over again, gives us a string. It's the only thing readline can do. It's the only way we can get data from question.
Yeah, when you're doing comparison for number of string and you compare it, is it also compare the data type or just the value of
Depends. Okay, so you really can't compare a string to an int without first casting them to like types. And then comparing the strings of two numbers versus the numbers themselves won't work quite the way you intend. because 1 and 10 both start with the same number, but 10 is longer. So it might not work the way you think it would, okay? So comparisons we'll get to a little bit, okay? In general, try to compare things that are the same data type. Otherwise, you'll get usually a compiler error. But there are some times where even the compiler isn't smart enough to know what the data type is going to be ahead of time, as we'll see when I go into the tests. Okay, so printing things to the line, yeah, this is not a big deal. So again, nothing crazy. This is where things get interesting. We haven't really done a whole lot of string manipulation. So, first thing, the compare. You wanted to know how we compare strings? Well, this is how we do it. We can say string.compare, which is a static method, which means the class name is before it, and then you give it two strings. So you cannot say string1.compare. That's not what we're doing here. We're saying string.compare, we give it two strings, and then we provide a single term to determine whether or not we're being case insensitive or case sensitive. What does that mean to be case insensitive? Could you be more specific than capital letters? Go to the third row. Against what? You saying that they don't count at all? You're just insensitive to capital letters. Second row.
Just treat the capitals and lowercase.
Yes, a capital A is the same as a lowercase a. In ASCII, capital letters have a lower numeric value than capital letters have a lower numeric value than uppercase letters. Third time, capital letters, a capital A, has a lower numeric value than a lowercase a. I don't know why that was so difficult for me to get out there. But a capital A is a hex 41. A lowercase a is a hex 61. Or 65 and 97, I think, in decimal. So a case-insensitive search will treat those two letters as the same quantity, whereas a case-sensitive search will compare and say that capital letters are less than lowercase letters. Now, the return type is actually a little bit weird, and it's a legacy of C. In C, there was a function called strcmp. You guys remember that function? Okay. This is the same. If the two strings are equal, you'll get a 0. They'll null each other out. They'll cancel each other out. If one string was further on in the dictionary than another string, you would get something that was either less than 0 or greater than 0, depending on which was before or after. So if string 1 is before string 2, you get something that's less than 0, before 0 on the number line. If string 1 is after string 2, you get something that's after 0 on the number line. What that number is not really important. You can't really read anything into it. But if it's equal to 0, the strings are equal. If it's less than 0, they're less than each other. If it's greater than 0, they're greater than. The string 1 is greater than. Now, greater than just means closer to the letter Z, closer to the end of the alphabet. Less than means closer to the beginning of the alphabet. Okay? However, C# is a little bit easier. We can actually do a case-sensitive compare. If we care about case, we just use the equals operator. It's been overloaded to provide string comparison. This is something that wouldn't have worked in C. It would have ate your face because it would actually be comparing two pointers. This, even though string 1 and string 2 are reference types, they're technically pointers. This is going to actually compare the data that the pointers point to. You can also use the instance equals member. So there's actually an instance equals and a static equals. Remember, static is the class name .compare. Instance is equals. So compare just gives you equal to 0, less than 0, greater than 0. Equals returns a Boolean. Obviously, I would choose the equals because it makes the most sense to me. But for you, mileage may vary. You may like to say string 1 dot equals string 2. Certainly reads a lot better. Okay, so what we've got here, I believe, is a linear search. Find the first string in a lexicographical order. Okay, so this is not quite. This is a linear search for the earliest value, meaning the value closest to the beginning of the alphabet. So these are a bunch of towns. Bulgaria, right? What is the town that is closest to the beginning of the alphabet? Sure, I'll go with Burgas. Except Burgas.
I don't know about the name.
Anyone know? I'm always looking to learn new things. Yeah. Borgas. We'll go with the Americanized Borgas. The reason this works is we start with a result. The result is the first town. That's the town we want to find. And we just make an assumption that it's the first thing in the list. We assume that Sofia is the earliest value. It's not, but we assume that it is. And then what we do is we go through each element, starting with actually the first element, item 1, not item 0. And we say, okay, the current town is Varna. And then we say, okay, string compare Varna to Sofia. What is the result of comparing Varna to Sofia? Let me go back and I'll go to the compare. Varna is string 1. Sofia is string 2. What am I going to get as a result? Varna is string 1. Sofia is string 2. So is string 1 before or after string 2? I don't think so. Varna is after Sofia. My alphabet, right? S comes before V? Okay. So in this case, since Varna is after Sofia, I'm going to get a number that is greater than 0. Is everybody okay with that? Okay, so we come back. Now, we're going to get something that's greater than 0. Is something greater than 0, let's call it 5, is 5 less than 0? No, of course not. So we're going to skip it. Now, we're going to come back up. We're going to get the next one. So first town is still Sofia. Now current town is really Plovdiv. I have a pressing urge to watch The Hunt for Red October now. Plovdiv. Is Plovdiv before or after Sofia? Someone from the left side of the room. Not unless you say the alphabet different than I. It's before. Plovdiv is earlier in the alphabet. Okay, so in this case, we will go into that if clause, and we will assign first town to be Plovdiv. Then we're going to be comparing Plovdiv to Plevin. Is Plevin before? Redeem yourself. It's before. Why? The P is the same, the L is the same, the E is before. How many of you have ever had to look up somebody's name in a phone book? Is that a thing that you guys do anymore? Like an actual phone book. The yellow pages or the white pages? You have. Sure you are. Okay. This used to be a skill that you learned early on, but I guess, how do you find somebody's phone number now? You just look them up in your contacts? You don't just be like, call my friend, my brethren, my good fella. My phone just does that. And really, I only call like 3 people. So I don't really need to know a lot of numbers. Where are we going? Oh, Plevin. All right. And then Borga is before Pleven. It's a linear search. All we're doing, though, is running the same test. I think it's worth it to go step through this one. Don't you? Just once, I want somebody like, nah, we're good. No takers? Nobody wants to be that guy today? It's too bad. Maybe another day. So, here we go. I know that I have not changed over yet. Goodness gracious. So now go to Visual Studio. Finding the smallest string. So the smallest string just means the one closest to the beginning of the alphabet. So let's start right here and debug. So first off, this is a array. We've done arrays. This is not a list. What's the difference between a list and an array? Lists are dynamic. What does it mean to be dynamic? It means you have a great personality.
It can change the size.
Can change its size. This array, it's allocated statically. It's not going to change its size. So when we make towns, right before we started, get rid of this command prompt. Town is null and first town is null because they're strings, they're reference types. As we go through it, we get towns. Towns is now an array of 10 strings. There they are. Okay, first town is now Sophia. So the first time through, current town starts off as null, becomes Varna. Varna doesn't trigger that if clause. Second time through, Plovdiv, we saw, does go in, finds Plovdiv. Okay, now we're comparing Plovdiv to Pleven. And Pleven is now the finder. Third time through, we're comparing Pleven to Borgas. And that also triggers it. The rest of the time going through this, we don't trigger that if clause at all. So at the end of this iteration, got two more left. Velkio Tarnovo and Yamble and Sylvan. We are done. We print out that the first town is command prompt visible. First town, Borga. Any questions there? The actual algorithm is a lot more interesting than the compare operation. Okay. So the next thing we can do is make larger strings out of smaller strings. This is where C# begins to lose me a little bit, because all three of these things that you see on screen do the same thing. They concatenate strings. However, the overhead, meaning the amount of processing power that you don't see involved in these operations, is not worth the simplicity of the way this works. So, string.concatenate will take those two strings, make a new string that is the result of sticking both of them together. So if string 1 is Bob and string 2 is Vila, you'll get a new string, Bob Vila. Who is Bob Vila? Nobody knows who Bob Vila is? Yeah, you're old. That show, We Build Old Houses. Are you referring to the classic show, This Old House? Local to the New England area, running for 30 plus years, if not longer. We build old houses. I love it. They don't just build them, they renovate them. Bob Vila, yes, host for many, many moons. So now we go on to the next option. It's actually quite nice. You can just use plus to concatenate strings. However, you should never, ever do this. Plus is a binary operator. It takes two operands, the thing on the left side of the plus and the thing on the right side of the plus. That seems fairly self-evident. But now we've got string 1 plus string 2 plus string 3. There are two pluses. How does this get evaluated? We can only take two things at a time. So what do we do? What do we concatenate first? So somebody said it over there. String 1 and string 2. Why not string 2 and string 3? Or string 1 and string 3? Because they're first. It's the order of operations. You do things like multiply before you do addition. You evaluate things left to right in almost all cases. So we take string 1 and we concatenate it with string 2. What's involved in that? First, we have two strings. They're reference types. The strings are allocated on the heap. So we allocate a new string. We take the length of string 1, the length of string 2. We allocate a new string that is the sum of that size. So let's say that we've got Bob Veal, or this old house. How many characters are in this? 4. And then how many characters in old? 3. So we allocate a new string that's 7 characters. And then we copy character by character into this new thing. So we copy from string 1 into the beginning part of this buffer, and we copy from string 2 into the end part of the buffer. So now we have this old. I know I'm ignoring spaces, so sue me. Now we have this new 7-character string, this old. Now we have this old plus string 3, which is house. How many characters are in house? 5. So we take 7 characters and 5 characters. We add that up and we get 12 characters. We allocate a new string that's 12 characters. Then we copy in the 7 characters from that string we just created. And we copy in 5 characters from the first string. And we have this new string. Now, just bear with me. We've got this, we've got old, we've got house, we've got this old, and we've got this old house. So to do this concatenation, we had to create a middle string, this old, copy everything into it. Then we had to copy from that into the third string, or the fifth string, depending on how you're counting. And then what happened to that second string? What happens to that middle string? We never use it again. It goes out of scope. It's never referred to ever again. This is extremely wasteful, which is why we're going to get into string builders. Just be aware that doing this, can I even point to it? Yeah, that right there, is awful. Don't do it. Doing this, almost as bad. You can do this, actually. You can concatenate strings with integers, but it's even worse than the second case. Because in the second case, you take 2 strings and you just copy some bytes over. In the third case, you take age. When you take a string plus an integer, it has to first convert that integer into a string, and then allocate a new string, and then copy the bytes over into that string. Bad news bears. But you can do it. Okay? It's possible. For tiny one-off things, yeah, not a big deal. If this was nested inside of a loop and you were doing this, some sort of recursive shenanigans, no. Write out. Better ways to do it. But it's perfectly syntactically correct. It will achieve the desired result. It'll just be slower than dirt. Or molasses running uphill on a cold day. If you watch This Old House, you probably get that reference. So, yeah, it's reasonable to say, okay, first name plus a space plus a last name gives you the full name. It works. If you take Svetlin Nakov and put it together, I apologize if this author ever comes and actually listens to these lectures. It's not my fault. I've got a cold. And yeah, you can make these look pretty reasonable. You can do formatted output using nothing but string concatenation. I don't think we need to see it because it's terrible. There are better ways. But before we get there, a few more things to manipulate strings. We talked about combining strings. we can also observe strings in interesting ways. We can do searches. In this case, we can find if there is a substring inside of a larger string. So if you have the string, this old house, and you want to find out if it contains the word old, you can use the index of. Now, index of, if you give it this old house, will return 5. Why 5? Well, because if you have the string this old house, you actually just do it like this. I can go to here, I can click on that and that, this old house. So here I am. Each of these columns, in the bottom corner of my screen, right about there, it says what column I'm on. Now, unfortunately, this was written by people programmed in MATLAB, I think. That's not true. This is written in C. It's not MATLAB, honestly. So column 1, though, is the T. So everything we do, we're going to have to take with a grain of salt here. But if I look at the index for old, this is character 0, character 1, character 2, character 3, character 4. The O is character 5. So when you ask for the index of old, so let's do something like this, string Bob equals, you would think that there was a theme here, but it's completely unrelated. Bob just happens to be a name I use a lot. Bob dot, actually, is that a static or an index? Checking. Yeah, okay, good. Okay, index of old. That's going to return 5. Because old starts at 5. Even though it's 3 characters long, it's 5. Now, this is still going to return 5. Because index of returns the first index. There are some other ways we can get around this. First off, there's the option to give a starting index. So we can say, okay, I don't want you to start at index 0, I want you to start at index 6. In which case it would return some number. I'm not going to count out those characters. Or we can start at the reverse. We can start at the end of the list and work our way backwards to find the last index of. Okay. Just gotta get to the right place here. So all of these options here, this is a instance method, index of. Okay. And so the string is C# programming course. So if you find index of C#, it's a 0. Index of course is 15. Index of course, all capitals. Problem with this is it's case sensitive. It means it cares. A capital O is not the same as a lowercase o. So when it cannot find something, it returns -1. So that third example there of index of returns -1. Is the word RAM in a C# programming course? Of course not. It's 3 words. C# programming course. But it will still find the index of RAM. Because where is it? It's right after the G in programming. Everybody see it? Before the Ming, after the Prague? RAM. So it's not like it's finding words, it's just taking whatever string you give it, it's going to find those things. It gets really interesting the smaller the search string is. If you try to find R, it will find every single R. And if you want to find multiples, just start at the index after the place you started. So if you said string index of R, it gives you 4 because it's C# space P R. That's the index of. If you said index of R comma 4, you'd also get 4. So to find the next one, you have to start at the index after the one you just found. You could turn this into a while loop, and you could say while string.index of does not equal -1, keep finding the index of. Everybody okay with that? I think I'm going to skip this live demo, so I'd like to get to the good stuff here. Substring is another function. This is something that's actually very similar to a function you'll find in Excel. If you've ever used Excel for string processing, because it does happen, I use this all the time. And every semester I actually use this function in Excel, because when I export your roster into Excel, it gives me fields that are unhelpful. So I just use some Excel formulas every year, the same formula to split your username into first and last name and get rid of the @UMassD to get your username, things like that. So here you can see what the substring function looks like. It returns a brand new string. It does not alter the string that it's operating on. So file name is not not modified by using the substring operator. You just give it a start, index, and a length. So starting at position 8, get me 8 characters. And if you count out the position C:/PICS/ R is the 8th character, index 8. And then get 8 characters, so RILA 2009 gets the file name. Now, how do you figure out what those indexes should be, the index and the length? Well, that depends on your application. You can also just get everything after a certain point. So if you just give it a start index, the length will be till the end of the string. So we've talked about index, we've talked about substring, sorry, index of and substring. We've talked about concat and compare and equals. Splitting strings up is a little more interesting. And this is actually a very useful feature here. You can use string methods to create arrays of strings. Here we've got a method called split. Split will take any string and chop it up into smaller strings based on some delimiter. For example, if you've got a CSV file, a comma separated variable file, it's a bunch of lines where each column is represented by some string in between commas. So if you split based on commas, you will get an array that's basically each of those lists. So anytime you have some sort of a list that you have as one big string, you can split it up. Now this is going to introduce some interesting things, but it does return an array of strings. So when we split the strings, this is where things get a little interesting. Swap over to Visual Studio. So this is as it originally was. Amstel, Zagorka, Tugborg, Bex, and for today, Puppers. So we run this today, and what we'll get is one line per beer. So if I run it, it'll print out each beer on its own. If I run the correct one, splitting strings. One beer per line. And on the surface, that looks like it works, but one beer per line. Command prompt. One beer per line. On the surface, that looks like it works, but that's because there's some hidden magic. I say if beer does not equal, quote, quote. Let's go back in after the split, but before we print them. Let's look at what happens when we run this. First off, we've got this variable beers. It's already been assigned. It's a list of 10 strings. I can tell because it says 10 down here. How many beers are there? I mean, based on the list. There are 5 beers. 1, 2, 3. Yeah, Puppers is the 5th beer. Why then do I have 10 strings? Well, I've got Amstel and then a blank. Zagorka and then a blank. Tubborg and then a blank. Beck's and then a blank. Puppers and then a blank. That's because of the way I split things. If I just split on commas, this would be a little bit different. Let's split just on commas for a second. I split on all 3 of those characters. If I rerun this, by the way, while this is compiling, exam on Friday, Wednesday is tomorrow, and is review day. So I'll go over briefly what the exam is going to look like, what you can expect, and then I will open the floor to questions. I will write code for you. I will go over topics for you. I'll do whatever you want. I think I will have to take the first 10 minutes and just go over a few more string things. Let's look at this list of beers. Now there are 5 beers, but look at the strings. May not be immediately apparent what's wrong with these, but look at the last. Can you see that from that far away? I may have to print them up on the screen. The Puppers has a period after it. Let me actually just let me print it out. Okay. This makes, of course you can't see it. This makes it, no it doesn't. What the hell is that? Oh, I've got 2 windows open. Better. This makes it a little more clear what's going wrong. What's interesting about the 2nd, 3rd, 4th, and 5th one that isn't true about the first one? There's a space. If we go back to the list, you'll see that's because we put a comma and then a space. So if you take out everything that isn't a comma, you've got space Zagorka. So that leads me to this last piece here. Let me put this back the way it was. We could add one extra option to split, to remove empty entries. So here we split, we say, okay, we don't want commas, we don't want spaces, and we don't want periods. So all 3 of those will be split on, but we won't save any empties. Okay, the reason we had those empties before is because it assumed that between this comma and this space, there was an item. What's between the comma and the space? Nothing. So we got a string that was empty. Okay, so if I do this, run it, now we get, especially if we get rid of the old one, we get everything back the way it was, no special stuff required. I can even get rid of the clause here, rerun it. Still no extra stuff necessary. Okay, question?
Is there a way to remove specific characters from a string?
Remove them. We're going to get into string builder. That's the last thing I got to cover. I know I'm out of time, but let me just very quickly throw a preview of coming attractions. You can replace things, you can delete substrings, but because strings are immutable, the replace operation does not change. So here, cocktail does not change. No, you can't see it. Okay, here you say vodka, martini, cherry. It's replacing the plus with ands. Vodka and martini and cherry. That doesn't change cocktail. Strings are immutable. You can create new strings, but you cannot change strings as they exist. Removing from index 2 for 3 characters does not change price. It creates a new string called price. What we're going to talk about on Wednesday, first 10 minutes, changing the things. Always it's creating a new string, trimming white spaces, all that. String builders are the solution to that, okay? We'll do that the first 10 so minutes, then I'll have 5 or 10 minutes where I'll talk about what the exam is on Wednesday, and then the exam is Friday. If you can, bring a laptop or something so that when I put the link out, I'm going to email it to everybody standing in front of you. I'm going to make sure that everybody has it correctly cloned, and then that's going to be it. You guys are going to be dismissed. You'll have until, I forget if I said Saturday or Sunday, at noon. Noon is the deadline for the exam. You must have pushed before noon. Here's my advice to you. Push often. If you don't get the last 5 points because you're working down to the deadline and you push 2 minutes after, if you push for everything but those last 5 points, you get a 95. If, however, you don't push anything until 11:59 and 50 seconds, there's a chance you're going to get a 0. Some of you are going to be super disappointed because zeros are going to happen. And that's not something I'm proud of. It's just something that, based on experience, is going to happen. It's not really a negotiation here. You've all been forewarned. What is the time the exam is due? Noon. I didn't say what day. I said what time? Noon. Question. For you, it's due Friday at midnight. You can turn it in early, guys. I'm not making this to be a day-and-a-half long exam. It should take you no more than an hour. Maybe 2 if you're slow at typing. Okay? Other questions? I mean, do you want a day-and-a-half long exam? Because I could write that. No? Everybody's good with the 1 to 2 hour exam?